Greetings, Hacksters, and welcome to our, what number is this? Welcome to Impact Spotlights. This is our free monthly event where we get to highlight Hackster community members and the amazing projects that they are making and the technologies that they're using in order to enable a better world. It looks like our Facebook stream is not quite working, but alas, for everyone else, we will just get started here. So you may have caught some of our previous events. If not, welcome. Welcome if you did as well. We've got 4 amazing projects for you today, including we've got smart heater control, we've got a smart do not disturb sign, we've got a tap that changes the color of your water based on its temperature, and we have a little companion bot that changes its expression to show you what your room health is like, and we'll dig into that. 4 wonderful presentations, as well as a quick word from our sponsor, IoT Connect, for this month. These folks are very much invested in the area of smart homes. We choose sponsors to work with that have their own motivations and their own investment in this area. So there's going to be a webinar coming up with IoT Connect, and in between a few of the sessions, you will see a message from them about the upcoming webinar. So be sure to go and sign up for that. As always, you can find links in the description of this video relating to the projects that you're going to see today, as well as our overall Impact Spotlights page, and where you can sign up to receive notifications about future events, as well as those webinars and things that we have surrounding these events. So I'm very excited, as usual, about what we've got for you today. I'm going to kick things off. As you can see, I'm very excited about robots. So I'm going to kick us off with our smart room health indicator via emotions on this companion bot, Gus 2.0. Let's have a look.
Hi, I am Arpan, an engineer and an artist. I have a YouTube channel called Makestream. The great thing about having an interest in both engineering and art is that I'm always looking forward to merging the two worlds, making art more interactive and tech more beautiful. So I came across this video talking about how bad air quality can make you feel drowsy and dull. I immediately got an interesting idea. You see, smart home sensors are becoming more and more common these days, and they display continuous numbers that can sometimes get overwhelming. That's when I built this cute looking robot. His name is Gus. This is actually version 2 of Gus. He has a bunch of sensors behind his head that track the air quality, humidity, and temperature in his surroundings. Based on how good or bad the conditions are, his eyelids drop to indicate the conditions visually. If his eyes are barely visible, it's probably a good idea to open a window or turn on the fan to get the air circulating a bit. He also blinks randomly just to add a bit of liveliness. In case you'd like to get back to the numbers and see what the sensors are actually reading, you can give him a gentle tap on his head. There's a tiny touch sensor that detects your touch and displays the numbers. His body was designed in Fusion 360 and 3D printed using PLA filament. His brain includes an ESP32S3, although you can use any microcontroller that fits inside his tiny body. His eyes are displayed using a white OLED display. When it comes to the code, we have the sensor readings as input. For each sensor, I have set a predefined comfort level. Based on how many of these sensors are outside the comfort level, we calculate an overall comfort score. This score determines how low the eyelids will drop. When the touch sensor detects touch, the display simply prints what the sensors are currently reading. In terms of where to take it from here, I think the code can be refined a bit. I'm not the best at programming, so maybe this is not the best implementation. And probably we can add more features and emotions with a higher refreshing display. I've gotten a lot of ideas and suggestions from viewers on my video as well as Hackster. If you want to check out the full build tutorial, I have a video on my YouTube channel. In fact, I have more such creative projects on my channel, so do check them out. Anyway, thanks to Hackster team for inviting me to present this project. And thank you all for watching.
Awesome. Love a tiny bot. I think the expressions on the little face are so cute. Honestly, that's one of the most fun things about Creating a robot is designing its personality and shaping its physical form and active and behaviors to sort of reflect that. So our next one coming up is a smart do not disturb sign, which is something that I definitely could have used in my last place when I was sharing office space with someone else and I had to tell them when I was going on air and things like that. So, this speaks to me personally very much. And this one is from Daniel Nemeth. Let's have a look.
Hi, my name is Daniel Német, and I'm here to present my Smart Do Not Disturb sign project. I'm from Budapest, Hungary. I have a bachelor's and a master's in computer.
Hi, I am Arpan,
I'm
an
sorry,
engineer
I'm
and an
having a little
artist.
bit of
Have you
trouble seeing the video. So, if let's see, I'm gonna see
And
if
I'm
that'll work
currently a
again.
PhD
There
student
we
and
go.
part-time software engineer. On the side, I like to do fun projects. I have been doing electronics projects since high school, and I have also attended many hackathons and contests. In today's talk, I will firstly introduce the problem that I was trying to solve with the Do Not Disturb sign. Then I will talk a bit about the hardware and the firmware side of the project. And then at the end, I will demo it as well. You can see that the sign is already behind me. To understand the motivation behind the project, we have to go back to 2020 and the first COVID lockdowns in Hungary. During that time, I was attending university, so we had online classes, but my brothers kept entering my room during classes or during tests, which was very annoying. I'm sure many of you who were studying or working from home during COVID have experienced similar issues. And to solve that, what I did was to wire up a couple of LEDs to an ESP8266 and then had this sign in front of my door with a couple of LEDs which indicated whether or not I was in class. Similarly to how you would have these on-air signs in radio stations to indicate if there was a live broadcast. But this was just a prototype and I knew that I wanted to eventually design something better. And in 2023, when I heard about the Make It Matter contest, I knew that I wanted to revisit this project and create a better solution for this problem using Matter. To get started, I used the NRF 7002 development kit, and this gave me some constraints around the dimensions of the smart do not disturb sign that I wanted to design. I wanted to have the same X and Y dimensions as the development kit. And I also knew that I wanted to have some cool animations, not just a couple of LEDs wired up. So RGB LEDs, NeoPixels were a must. But the question was how do I want to arrange it? Do I want a simple matrix or do I want to make it something more unique? And for that, I had these semi-transparent LED diffuser tubes ordered from China, and I arranged 5 of these below each other and then wired NeoPixel LEDs to them to create this sort of LED matrix, which in some sense was just several row of pixels, but it was actually something where I could draw patterns on it as if it was a matrix. Here is the casing that I designed for that, which was later 3D printed. The bottom part houses the development kit, and the top part has these 5 tubes on top of them, and the 2 pieces on the side cover up the wires that are used to connect the LEDs together. I had to use a logic level shifter since the microcontroller used 1.8 volt logic level, which was not enough to drive the NeoPixel LEDs. So I wired up this logic level converter and a couple of resistors in order to drive the LEDs. For assembling the display, I wired together the LEDs in this zigzag pattern and connected the 5 volt and ground connections on one side. Then I glued these tubes with double-sided tape to the base plate and then covered up the wires with the 2 pieces on the side. For the final assembly, I connected the display wires to the output of the logic level converter, closed everything up, and the hardware part was ready. For the firmware part, I of course used Matter as the communications protocol, Matter aims to be the protocol for IoT devices, and its major selling point is that both Apple and Google support it, and also that it allows the development of ecosystem-independent devices, wherein I don't have to worry about whether or not something will be compatible with an ecosystem, because this common protocol will enable me to connect my device to any Matter fabric. To learn more about the development kit and also about Matter, I watched a couple of courses and webinars, which are all linked in the project page. The first task was to actually design what these clusters and actual endpoints should look like for the communication between the Matter fabric and my actual device. And for that, I only cared about one cluster, which was this level control part, where I wanted to specify the state of the display. So I wanted to have 3 separate states, one for the display's off state, and 2 for the busy and free animations that would happen on the display. So the ZAP tool was used to specify that, and then once I generated this Matter template code, I got started on modifying that to include all the animation part and also wiring everything together from the Matter side to the display side. The LEDs were controlled over I2S, and I've created helper functions to map from this zigzag connection of LEDs into a 2D matrix, and then specified a couple of animations and also connected up the Matter state to the display state, so that whenever there is an update arriving to update this level control cluster, then that is actually reflected on the display. To use the display, I needed to connect it to a Matter fabric. Here, I opted to create my own custom fabric instead of connecting it to Google's or Apple's ecosystem. And the process of creating the custom fabric is well documented in one of Google's example projects. This Android application is capable of having its own custom Matter fabric and commissioning devices onto that. So I used that as a basis of my own custom fabric and modified the application so that I have these 3 different states of the free, busy, and also the off state represented in the application, and the device communicating with my sign. And how the process looks like now after I install the application on my phone is to simply tap the plus button, which takes me to this Matter commissioning code, where I could enter either a pairing code or scan a QR code to pair the device to the Matter fabric. Here I opted to enter the pairing code, which is printed to the serial output of the Do Not Disturb sign, and then the commissioning process starts. The microcontroller connects to my local Wi-Fi network, and from that on I can specify a name for the device and then control the Do Not Disturb sign from the application. So here you can see the 3 different states represented in the application. And as I said earlier, there are some nice animations involved for the free and the busy states. You can see one photo for each of these states. And then, as I said earlier, I can demo the project right now. So here I have the application on my phone. I have the Do Not Disturb sign behind me. So if I tap on the free state, then you can see that this nice green animation appears, which indicates clearly that you can enter the room. And then whenever I join a meeting or I attend a class, I can just from my phone tap the other button, and then it will switch it to this busy state, indicating that I'm currently attending a meeting and you shouldn't enter my room. And I want to say thank you for watching this presentation. You can find the source code of the project and the guide on the project page, and you can also find me on LinkedIn and on GitHub. Thank you.
Awesome. As mentioned, you can find all the links for these projects after the fact. After we wrap up this stream, we're going to add those to the video description. If you just scroll down, you'll be able to find those. Also, at the end of today's program, we'll be putting those in the chat here, and I'll be pulling them up on the screen so that you can easily find all the people that we've highlighted today. We want to make sure that it's all in the spirit of sharing and like learning from each other. So there's definitely some stuff there that I'm interested in digging into, including the links for those learning resources that Danielle mentioned. Awesome. So now we have a message about our upcoming webinar. As I mentioned before, today's program is brought to you by IoT Connect, powered by AWS, and we have a short message about the upcoming webinar that they'll be presenting surrounding that. Let's have a look.
Hi, my name's Keaton Anderson, and I'm with Avnet's IoT team. I wanted to talk quickly about our Hackster Impact Spotlight coming up in June featuring smart home. As smart home technologies have become more mainstream, a wide variety of manufacturers have developed new devices focusing on everything from smart doorbells and locks, to TV and lighting control, to even smart pet feeders and appliances. Given the wide nature of communication protocols like Zigbee, BLE, LoRa, and Matter, the onboarding experience can sometimes feel something like this. Ah, finally I'm able to sit down and enjoy my new smart home. I just need to go in and turn down my thermostat to the perfect temperature. Oh, that's right, I need to make an account to link that up. Well, no worries, I can just turn on my smart TV and watch some Oh, right, that requires a different app. Well, at least I can turn my lights on, right? Oh, goodness. During our upcoming webinar, Avnet will partner with AWS to talk about IoT Connect and AWS managed integrations and how they help solve smart home device challenges. IoT Connect is a SaaS IoT development platform that takes all the AWS services needed for IoT development and deployment and aggregates them into a single user experience. By combining this with AWS managed integrations, we can take the various communication protocols and standards and help bring them into a single common interface. We will dive deeper into how to get these devices connected and how IoT Connect can help make your device onboarding seamless. I'm now going to turn it over to Olivier, who's going to talk to you about how to enable your smart home devices through AI.
Good morning and good afternoon. This is Olivier Bernard with AWS. I am a principal IoT specialist, and I lead our go-to-market strategy for AWS IoT services into consumers and smart home products more specifically. AWS IoT is very excited to announce our partnership with Avnet to deliver an upcoming webinar this June. In this session, we'll introduce an innovative new service that we recently launched at Mobile World Congress, MWC in Barcelona, and which is fully integrated with Avnet IoT Connect platform. This new service, called Device Management Managed Integrations, is designed to elevate the use and productivity of smart home devices through the use of AI at the edge. With managed integrations, smart home devices can utilize real-time data processing and AI modeling tuning to continually improve user experience and device reliability. Devices will make intelligent and contextual autonomous decisions with continually trained user behaviors. So, to learn more about how AWS IoT and device management managed integrations with IoT Connect are simplifying the smart home use cases, integration, and deployment, come see our webinar this June. Until then, thank you for your time and see you all in June.
Awesome. I guess we'll be there in June. Again, thanks to our sponsors for bringing today's program to us. I love doing this. We love it that you all seem to get a lot of value out of it, which is exactly what we're going for, as well as getting to highlight people in our community who are doing just really cool stuff. So here's someone who has contributed a lot to Hackster over the years. It's been a while, so this name is very familiar to me. Arnav Sharma is going to tell us about a smart room heater plug. Let's have a look.
So this is the smart room heater plug project. Let me first introduce myself. Hi, my name is Arnav and I work as an R&D engineer for a lighting sector company based in India. My area of expertise lies in product design, on an emphasis on mechanical stuff, mold and product assembly, and all the fascinating details that goes into developing a lighting product. In my free time, I love channeling my creativity into personal project, which I then proudly share on maker platform like Hackster.io. It's my way of connecting with like minded individuals and maker community to exchange ideas, of course. We created a Wi Fi smart plug for remotely controlling a room heater. The smart plug features a Xiao ESP32C3 microcontroller and custom relay board, which can be used with a heater in winter and an air conditioner in summer. Using a web page, the user can easily turn the device on and off from a tablet, smartphone, or PC. We started by using one of our previously developed Xiao relay driver board along with a socket and plug. To optimize the design, we minimize the size of plug and socket by removing the excess material, keeping only the essential components. The model of this project is separated into two components or section, the socket section and the plug section. The plug section houses the plug and circuit, while the socket section contains the socket part and Wi-Fi antenna. Both sections are held together with M2 screws. For two color theme, the socket part was printed in transparent PLA and the plug section was printed in grey PLA. To test the smart Wi-Fi plug, we plugged it into a 16 amp socket and attached a room heater on the onboard socket. After turning on the device, the Xiao ESP32 connects to Wi-Fi and allow us to access the device web page. Using the web page, we can turn on or off the relay that controls the load connected to the socket. For now, the web page only has an on and off button. However, I plan to enhance the web page and make it more visually appealing and include additional feature like a timer. This timer feature will allow user to set the device on for a specific duration of time. Another priority is addressing the size of the plug, which is currently quite large. In the next version, I aim to reduce its size by designing the plug from scratch and incorporating the mechanical part directly into the design. My ultimate goal is to create an open source smart plug that is both portable and customizable, enabling anyone to build their own and tailor it according to their needs. Well, this is it for this short video, and thank you.
That's so cool. I love seeing familiar faces on here. And that Hack to the Future t-shirt is a huge throwback. That t-shirt is, I think that might be a reprint, but it was originally designed 10 years ago for the Hackster Hardware Weekend series of hackathons across the United States. So we bought a DeLorean. Our founder Adam Benzian bought a DeLorean off eBay. I love telling this story. It's awesome. We brought it on a tour around the US and let people hack different projects on top of it. So cool. Anyway, so seeing the Hack to the Future sure just makes me smile. All right, so our final presentation for today is I think this one is really like sci-fi and a little bit cyberpunk. We've got a smart tap that changes the light of it like you'll see. It changes the color of your water based on the temperature. It's really cool. Okay, let's go.
Hello everyone, my name is Nagar Rafid Dalatabadi, and I'm more than excited to be here today at Impact Spotlights to present my project and talk about how this innovation can make changes. So my project is about developing a smart temperature lightning water tap with the usage of Sensorion SHT45, which is Sensorion temperature and humidity sensor. So just to give you a little bit of background about myself and how this project is related to my occupation, I'm actually a field application engineer at Sensorion based in Chicago. I've been with the company since 2023, and I'm an expert in sensor integration and IoT applications, which I usually develop for our customers. I'm really passionate about smart solutions and sustainability, which is also a target goal and area of interest for the company as a whole. And I've developed this smart water tap using Sensorion SHT45, which is the latest and greatest generation of Sensorion temperature and humidity sensors. And the target goal for this project has been to enhance the user experience by providing real-time water temperature feedback using Sensorion SHT45 and also showing it to the user using the LED indicators. So the inspiration for this project has been the problem that usually no quick visual indication of water temperature is available for the water taps, which may lead sometimes to discomfort and inefficiency. I had experienced this personally sometimes. And also, I'm really interested in integrating the new technologies to solve the everyday problems that we face. So I really liked how SHD45 can be used to provide an accurate temperature sensing for real-time feedback for such, ordinary and everyday issue. The sensor is super accurate. It is actually having plus minus 1 degree C accuracy in terms of temperature, which makes it super convenient to be used in such projects. And the solution I came up with was a smart water tab using this sensor, which the sensor is implemented to measure the water temperature. And then the LED color changes like based on the temperature of the water, which provides instant visual feedback. So it is actually defined in the Arduino C code that I upload onto the Arduino, how and in which ranges of temperature the LEDs should be, which color. So this is a color mapping defined in the code. And my hope for this project was that it can enhance the user experience and improve safety and convenience. The materials I used for this project, it was Arduino Uno Wi-Fi Ref2. It just works well with any type of Arduino, even with the ones which are not equipped with Wi-Fi module. The reason I chose this one is that I'm hoping that maybe in future, as a next step, I would be able to transfer the data from the sensor to a cloud service or like a web app or mobile app through the Wi-Fi, and make it even more developed. So the reason was that I really wanted to develop the whole system at a Wi-Fi featured Arduino at the beginning so that it makes it easier for next steps, but it just works well with any type of Arduino, I would say. And I also use Adafruit board, which contains Sensorion SHD45 temperature and humidity sensor. Since the sensor is already mounted there and it does have the pinout, it is just a very easy and convenient for prototyping projects. I used jumper wires to build the connection between the Adafruit board and Arduino, and of course Arduino and my LEDs. I use breadboard for prototyping, which makes it super convenient. I use LEDs, obviously 3 colors for the 3 different situations of temperature, like the ranges of temperature, blue, red, and green. And I also use 220 ohm resistors to build the connection between the LEDs and the Arduino, so for the circuit board there. So the way the final design look like, it is more focused in a simpler prototype, so it doesn't come with any packaging or enclosure around it. It was just a prototype to test the feasibility and functionality, and if just as a proof of concept, if it is really working or not. I used SRT45 for accurate temperature sensing, of course. As I mentioned earlier, it comes with a good accuracy of plus minus 1 degree C, which makes it convenient for this. And I implemented LED-based color feedback for intuitive temperature display. So this is something implemented in the code, which is uploaded on Arduino. And you can see, the whole circuit in the picture shown here. So I do have the Adafruit board connected to Arduino, and then the LEDs connected to Arduino with those 220 ohm resistors, which makes the whole circuit. And the biggest challenge I was facing during this project was the sensor positioning on the tab. I really had to try out different replacement of the sensor just to make sure that it is really reflecting the closest possible temperature to the water. And so it is, showcasing the reality of water temperature. And I also had to get the reliable LED response. So I had to kind of fine tune the temperature to color mapping in the code so that it is, the best case and in the optimal state. And I also had to manage the exposed components because, as I mentioned, it was an early prototype, so it was not coming with any type of packaging around it. So I kind of had to handle the wiring carefully and while keeping it also functional as a prototype. So the next steps that I'm looking forward for this project is, so firstly, to improve the design. So now I'm passing the proof of concept. So I really want to develop a compact enclosure for the real world usability and make it more look like a final product. Now, I also, as I mentioned earlier, would like to enhance the features, like exploring wireless connectivity for app integration or web integration. I also really like to, do some testing and feedback. I really like, to have some clients using it, like potential clients, and gather some user input to refine the temperature to LED mapping, because I think it is an essential part of the project. And also the potential applications that I'm looking forward for is obviously expanding the concept for smart home water systems. So this is the final application I'm looking forward for it. And Les, I really want to thank you everyone for your attention and your time. I also would like to have a heartfelt thank to my manager, Jacek Pixaba, for his motivation and unwavering support for this project, and also a gratitude to the entire Sensorion, a US FAE field application engineering team, for their constant and valuable guidance and collaboration. I really appreciate it. You may find this project page on Hackster. I included this in this slide, and you may also find my project and profile and access the other projects that I've uploaded. Most of them also include Sensorion sensors and products. So I really appreciate if you could review my projects, let me know what you think, and I would be really happy to see your feedbacks and insights. And I'm also open for collaboration, for future collaboration and different projects, so you can reach out to me, with the ideas. I also included my social media to get connected. So I included my LinkedIn. You may also reach out to me with my email. And I also added my personal website if you want to get in touch. Thank you, everyone, once more. Have a great rest of your show. And yeah, looking forward to hearing from you.
Splendid. Ah, those were awesome. I'm feeling actually really inspired. Um, ooh, especially, the enclosures question is always a huge one, and I poked around on a few of Nagar's other projects and saw that she does totally use enclosures in other ones, and I want to borrow some ideas from those. So thank you again for joining us for today's Impact Spotlights. We're going to be sharing the links to all these projects as well as the webinar in the chat, so jump on there. You can also find those in the description to this video if you are watching it in the future. I'm going to show you a few of these pages really quick just to make sure you know where to go. There's a lot of cool stuff around. Let's have a look. I'm going to add it to our page right now. Here we go. And pull this on the screen. Pardon, I'm having a bit of a complaint from our media thing. There we go. Haha. A few things have shifted around on me. But anyway, here we go. Impact Spotlights. This is our main page for all of these events. As Jesselyn, who is our wonderful team member backstage running a lot of this stuff from behind the show. Thank you, Jesselyn. We've got our Impact Spotlights main page, and she told me that it is, in fact, our 6th Impact Spotlight. So that's 6 of these events that we've brought to you. And we have some more queued up here. So if you look on our page, you'll find out that we have AI and robotics themes coming up April 24th, May 29th, June 26th, and July 31st. And in between all of that, we have that webinar from IoT Connect powered by AWS, which you can find if you subscribe to our announcements. You'll get all the announcements around upcoming events as well as that webinar. We'll also have it on the Hackster main page. So you can find out about all those in the future here as well, events.hackster.io/impact spotlights. You can also go and check out more home automation projects by going to hackster.io and looking up at the home automation page, which is under our topic pages here, as well as, of course, a ton of other projects like Internet of Things projects, robotics, sensors, displays, and a ton of other categories that I'm not going to go through all of them because there's a million of them. You can find previous recordings of our prior sessions on our Impact Spotlights playlist on YouTube. Be sure to subscribe so you don't miss any of our things there. Always we've got hardware unboxings, tutorials, interviews, virtual events, all this stuff happening all the time. You can find that as well if you just click on any of these Watch Now links or RSVP links in the future, as well as keep an eye out for these banners on our main page. Here are the project pages for each of the projects we saw today. So we've got Gus 2.0, our first one from Makestream, which is an amazing username. And you can find out more about the little robot and all the different stuff that went into it, which I think is awesome. This is designed in Fusion 360. I love it. As well as the pages for each of these people. So we've got a piano doorbell as well. All kinds of different stuff from our contributors today. Smart do not disturb sign. I love how this includes both like shapes as well as colors. Very accessibility friendly. Three more projects and a couple of contest wins. Arnov is a massive contributor. I just had to show you. Arnov has contributed 328 projects to Hackster.io. So massive shout out there. And I'm going to be checking out more of Arnov's stuff on the internet as well. Various time winner of various contests. And then, of course, we've got Nagar Rafidalattabadi with the Smart Temperature Lightning water tap using Sensirion SHT45, which you can find a whole right up there, and also more of her projects. Finally, be sure again to go to iotconnect.io and check out what they've got going on there, as well as keep in touch for that upcoming webinar. It's going to be really fun. And now it comes back to me. I am very excited to get the chance to share these with you every month. So be sure to tune in next month again. Thank you again for joining us. Thank you so much to our contributors. You make so much cool stuff, and I love getting to just like sit back and watch you talk about it because that is also very inspiring. So, and thanks once again to our sponsor for today, IoT Connect, powered by AWS. We could not do this without you. Appreciate you very much, and looking forward to that webinar. Thank you, everybody, and hack on.